say that. So my name's Elton. I wrote a book. You might have heard about it. It's a good book, but it's expensive. If you want a copy, email me. I'll send you a PDF. No questions asked. Don't film that bit because obviously that's blatantly in violation of all the copyright rules. So my name's Elton. I work for Docker. I've been here a few times to Docker London, but not for a little while actually. So I'm glad to be back. Thank you for having me. This session's about service mesh. I'm going to talk specifically about ISTIO with a nod to the Linkerd people who gave me the T-shirts that some of you have got. So very quick show of hands. Who's kind of played around with ISTIO or got a vague idea about service meshes? Cool. Well, I'm done, so I'll see. If you talk about service meshes, it's actually quite a difficult topic because the high level is quite high. Like you can talk about service meshes at a pretty high level to people who've got C, X, O in their title, and then the next level is way down here because you need to understand Docker, Kubernetes, and a whole bunch of stuff before you can see the demos. So I'm going to try and bridge that stuff. But the main theme of what I'm talking about is there's some tech demos. I'll show you how this stuff works and what it can do. But it's mainly about should I be investing time in this stuff because it kind of emerged very quickly in sort of 2017, and ISTIO kind of exploded. And if you went to KubeCon that year, it was pretty much ISTIOCon because all the talks were about ISTIO. But no one was talking about the evaluating whether it's going to give you something that's worth having. So that's what I'm going to kind of try and cover today. So I'm going to talk a little bit about what a service mesh does and can do. I'm going to talk about ISTIO and Kubernetes. Yes, I know it's not for me, but ISTIO only kind of really works with Kubernetes. Other service meshes work with other orchestrators too. And then the last thing is evaluating what this stuff can do and whether it should be part of your learning path for the next X number of months. So firstly, what is a service mesh? It's the communication layer of your application made into a separate entity. So instead of having all these bits having the logic to communicate with each other, you take that logic out and you centralize it somewhere else. So this is not an official definition, obviously, this is my definition. But the thing to note here, that it says software components. It doesn't say microservices, and it doesn't say containers. Those things are not prerequisites. A service mesh is about connecting things together. They could be big legacy applications. They could be nice, small microservices. So what does it actually mean? So here's about as simple as you can get with a distributed system. I've got two components, a website talking to a database. Now, for that communication to happen across a network, there's a whole bunch of stuff that the client, the website, needs to know about. So it needs to know the address. It needs to be able to find this thing on the network. It needs to have some logic in there to say, when I try and connect, how long should I wait before I think there's a problem and I do something else? If I'm already connected and I try and talk to this remote service and there's a failure, should I retry? How often should I retry? How long should I wait between retries? And then should I encrypt the communication between these things? This is all going to be baked as either configuration or logic inside the consuming application, inside the website. And that's kind of OK. Like, you can live with that. But as soon as you add something else, so I'm talking to an API as well now, turns out I need all the same things. I need to know how to find it. I need to know what to do if I can't connect. I need to know what to do if it fails. I need to know if I'm going to encrypt it and how. And so when you start, all these separate concerns are now in a completely different client library. So on the top there, I've got some sort of custom SQL driver. On the bottom, I've probably got an HTTP library. And I'm having to rewrite all this logic and deal with the fact. But actually, they're essentially the same concerns. And again, you can probably live with that. But when you start coming to a design like this, which is the Weaveworks microservices demo that's up on GitHub, then it becomes unmanageable because all these components are talking to other components. They've all got their own kind of databases. They're all posting messages to message queues and listening. All those things need all those same sets of concerns. And it just sprawls everywhere. And you can't manage it centrally. You can't say, oh, actually, our message queue, we know it's reliable now, so we can turn down the timeout time. You have to go to every single component and change the config, or worse, change the logic and rebuild it. So what a service mesh does, a service mesh is a separate thing. So it sits outside of your application. So I've got my components that I care about, and the service mesh sits there on the left. And it doesn't do anything until you actually register your bits with it. So I can register my web component with the service mesh, and then the service mesh is going to take care of all the communication from the website out. So I can put all the logic that I was capturing inside my web application into the service mesh. So all that stuff about where I'm going to find it, the timeouts, the retries, all that sort of stuff can live inside the service mesh. And I can have, if I control everything, then I can register all these components with the service mesh. And then not only can I do client-side configuration, so saying when the web makes a call to database, actually the real address is this URL, and actually the timeout is going to be 20 seconds instead of the default 10 or whatever. If I'm on the server side as well, then I can configure things like rate throttling and rate limiting and stuff like that. And I can configure encryption between the two components because I own them. So those 1, 2, 3, 4, 5, those hexagons there in pink, they're a proxy. And that's how the service mesh works. So basically, it injects a network proxy into your application component. So when your application thinks it's talking straight on the network to a component called database, actually it's going through the proxy. And the proxy is having rules applied by the service mesh, which says when the client thinks it's talking to database, it's actually talking to eu.prod.database.windows.net or whatever. Okay, so that's how it kind of works under the covers. That's the high level bit. And even if you can configure an external gateway, so traffic coming in from the outside world goes through your service mesh too, then you can put also all that rate limiting and all that encryption and all that stuff in right at the entry point to your application. Okay. So ISTIO. ISTIO is it came out of a Google project originally. It kind of spun up out of nowhere in about a year. So it's open source and it's platform agnostic with a big asterisk because that's a goal. It's a goal that it's platform agnostic. At the moment, not so much. Like 0.1 was in 2017 and the GA release was in 2018. So the growth was pretty huge. Other service meshes are available. Linkerd is a notable one, especially in the Kubernetes world, because it does a lot of what Istio does, but it's way simpler. So if you're starting in that world, have a look at Linkerd as well. And there are a couple of things that it does. So the Istio and Linkerd and Console from Hashi, I'm sure there will be others. They all have slightly different feature sets, but they're coalescing around kind of 3 main areas. The main one is traffic management. Because all the logic for the communication is inside the service mesh, you can configure how the traffic routes around between your applications. So you can do load balancing, you can do discovery, you can also do nice failure handling. So the routines to do a retry with an exponential back off and all that stuff, that's all inside the service mesh. You don't worry about how to write that code. And then security. So you can have components that have no notion of security. You can keep all these kind of infrastructure level concerns out of your application code. You don't need to have HTTPS communication between client and server. You leave that to your communication layer. So encryption, authentication, even authorization, certificate management and rotation, it can do all that stuff. And then observability, because all your traffic is going through this centralized component, it can surface all the metrics that you're interested in, and you can find out what's going on in between your components without having to, again, add all that boilerplate stuff into every single part of your application. It's optimized for Kubernetes, so because Kubernetes has this extensible layer, if you're not familiar with Kubernetes, you can plug different things in and have them managed by Kubernetes for you. So I can create a custom type of resource and tell Kubernetes that you manage this for me, and Kubernetes will look after them for me. Istio takes advantage of that and spins up a whole bunch of things and lets Kubernetes manage it for it. It uses Envoy, so the bit underneath it is actually proxying the network communication. That's a separate third-party component. So all this stuff, like although Kubernetes now supports Windows, Istio doesn't and Envoy doesn't. So if you are a cross-platform person like me, then you're not doing this stuff with Windows just yet. So what this looks like is when I've got my 2 services, and service A is a consumer of service B, all the logic I write is from how to get from A to B. I don't worry about any other stuff. So it looks like, logically, my call is going straight from service A to service B. When I deploy this through Istio, all my Istio stuff is running in the background. So it's all running as Docker containers, and they're all in their own components. What's actually happening is when I register these services with Istio, it's going to inject these proxies. So again, that's why this is a kind of a Kubernetes-specific thing, because Kubernetes has this notion of a pod that has multiple containers, and my application container is talking to the network, but it's routing through the proxy container, which is in the same address space. So the calls actually go through the proxy, and then all these different bits of Istio apply the logic. So this thing called Pilot is what has all the configuration that you set up centrally. This thing called Mixer is what joins in with all the rules, and then Citadel is the thing that generates TLS certificates and deals with rotation and that sort of stuff. So the thing about this diagram is the only stuff you care about is right at the top there, and there's an awful lot going on underneath, which is one of the things to bear in mind. So a service mesh does give you an awful lot of functionality, and if you've got a background in the integration space and plugging things together, then actually what you get from a service mesh saves you an awful lot of custom code, but it's not for free. So this is the only metric I've looked at here is how much code there is running underneath your service. So ISTIO, 2 million lines of code, Envoy, 250,000, Kubernetes, 3 million, and Docker's about 1 million. So I've got my hello world REST API with 1 line of code, and underneath it, the stack is 6 million lines of somebody else's code, which each have their own release schedules, they each have their own teams building it, potentially security flaws, potentially updates that are going to break everything. So bear in mind that you get an awful lot out of the application, but there's an awful lot that could potentially go wrong. Okay, so here's where the demo comes in. I'm using the demo, which is ISTIO's kind of standard demo. So, like, if this piques your interest and you want to find out about it, you can go to their GitHub repo and you can replicate all of this yourself. It's a really simple demo application. There's a Python web application which just gives you some information about a book, and it goes and gets reviews from a separate service. And that service, there are 3 implementations, reviews version 1, 2, and 3. And they have different UIs, and we'll see that in a second. When you deploy it all, then if you deploy it by default with Kubernetes, then it's gonna load balance between all those services. So each time I call it, I'll get a different response. And then with ISTIO, I can manage how the traffic is actually working. So you can deploy it without ISTIO. So there's just a Kubernetes manifest, which I'll show you if you're interested to deploy all this stuff. But if you've got ISTIO running in the background and you've got it configured, then when you deploy it using the same application manifest, ISTIO injects all these components, all these proxies to deal with the traffic. And what I'm going to focus on, because I'm already going to be over time, but even so, what I'm going to focus on is this bit in the middle, the traffic management that I kind of vaguely talked about. So there are other demos you can do, and you can see how security gets applied. You can see the observability. There's a whole bunch of different dashboards that show you what's going on that come out of the box with ISTIO, but I'm not going to cover that. Okay, so I'm just going to cover the traffic management part. And this is how it looks. So I've got my product page, which is my Python web application. It's talking to these review service. Because they're both containers, they're both pods running in my application, ISTIO can own both of them. So it's going to put a proxy client and server side. And all this stuff here is what actually happens when my product page tries to consume a service from the reviews component. So at the bottom there, I've got my container. So it's running in a Docker container, which is part of a Kubernetes pod. So those are standard resources. Above that, all these other layers are things that ISTIO injects. So when first of all the product page tries to get to the review page, it goes through this thing called a virtual service. And a virtual service defines a destination, and a destination has one or more subsets. And then eventually it gets to a pod and then into a container. There's quite a substantial stack here. The definition isn't too bad, so the things you're interested in are the destination and the subset, and this is what you can control the routing. So like I say, I've got 2 different versions of my application running, of my new service. Version 1, which is the live version, and version 2, which I'm doing as a rolled out, a staged deployment. I don't want lots of traffic going to version 2 because I want to test it out. So I can say, subset version 2, give it to 50% of the traffic, or 10%, or 1%, or whatever. No application logic, it doesn't change, it's the same application. It's being routed by this higher layer, by ISTIO. Okay, and there are different things you can do when you've got that principle in place. So firstly, you can do things like, as well as doing the routing and the load balancing, ISTIO can do health checks for you. So if you've got components that don't have a health check or are too complex to have an external health check coming in, then ISTIO can just do basic TCP pings, or it can do UDP or whatever to check that the thing is up and available. It will do retries for you behind the scenes. So if the communication fails, it doesn't go back to your application. ISTIO does the retry. And when it works, then it just looks like it's taken longer than it should have done when your app gets there. You can do quality control. So the routing that you do between component A and component B, you can define rules about that. And ISTIO is aware of certain types of traffic. So it understands about HTTP, it understands about Go, RPC. So it can understand the payload, and you can write rules based on that. So I can have if I've got a custom HTTP header that defines some subset of users, I can direct them to a particular release. And you can do fault injection. So you can do live testing in your actual live cluster, deploy your version 2, and have it so that only your test team are accessing version 2, and deploy a real genuine fault, add some network latency or add some random failures. So when they're testing this stuff, they can see how it behaves. but it's the real application, the real live production cluster. It's not affecting any of the other users. And the last thing, of course, is deployment. So blue, green, purple, red, whatever your colorblind friend has it down as. You can do all that sort of stuff, and you can do staged rollouts. So I can say, send 10% of traffic to this site, to the new application version, and then roll it out to 20, 50, 100, as I'm happy with it. OK, demo. So let's see how tiny my code window is. So this demo, I'm going to zoom in. This demo, all this stuff's on GitHub, and right at the end, I'll show you a link to how this works. So I've already deployed ISTIO, so I'm just running. Can you see the Docker whale up there? So I'm just running Docker. This is Docker Desktop on Mac and Windows now. It comes. This is such a tiny screen. It comes with. So this says Docker Desktop is running, little green light, and this says Kubernetes is running. So there's a checkbox to enable Kubernetes. So you don't need to add anything else other than Docker Desktop. So I've got Kubernetes running. I've already installed ISTIO. The GitHub repo has got all the steps for that. Basically, it's just deploying a bunch of Kubernetes manifests. So I'm not going to go through them in detail, but this is the custom resource definition. So I think ISTIO, the latest version, has got 53 different CRTs. Like I said, there's a lot of complexity there. The ISTIO itself runs as a whole bunch of services itself. There's 15,000 lines in this YAML file. So I'm going to start with line 1. No, obviously not. In fairness, most of that is a Grafana dashboard. So they plug in a whole Grafana dashboard as a config map and surface it. So I'm not going to go through all that. All you do is deploy those things, and then you've got ISTIO up and running. So I'm going to switch to the demo that I'm actually interested in. So let me show you what's running. So ISTIO deploys to its own namespace. So all these things are already running. There's some batch jobs that have completed. There's a bunch of pods. There's a bunch of all sorts of stuff that's all up and running. I deployed all that a little while ago. And I've also, what ISTIO can do, again, because Kubernetes is so pluggable, as part of the ISTIO deployment, it can register with the Kubernetes API to ask about new stuff being created. And if you apply a label to a namespace, this label here, then ISTIO will automatically inject itself into all the new things that are created. So when I deploy my application, this book review application, I just used a standard Kubernetes manifest. It's not 15,000 lines. It's a standard Kubernetes manifest with just several hundred lines. So all this is, there's no mention of ISTIO here. This is standard services pods, standard description. There's no ISTIO in here. But because I deployed ISTIO and had it automatically inject those proxies, when I ran this, each of the pods that had my application components had a proxy injected, and ISTIO is managing all that stuff for me. OK, so let's go back here to my demo. So I've already deployed this application, and it uses an external gateway as well. So you see what I mean? Like, we've gone from really high level to way down here. So if you're not following me, I apologize. There's a longer version of this session on the internet, which I'll give you a link to that in a second. So I've got this gateway here, this ISTIO gateway. That's the thing that's listening for all incoming traffic, and it's going to route to my my product application, which is here in this absolutely tiny window, which hopefully I can also zoom into. OK, so this is the demo application. Like, it's completely useless. It's just one product review, which is about the comedy of errors. On the right-hand side there are the reviews. So this is the product page that's consuming this review service, and there are 3 different versions currently live. And because there's no traffic management happening at the moment, it's just round-robining between them. Round-robining. That's a word. That's definitely a word. OK, so first thing I'm going to do is I can tell ISTIO to manage the communication between my product page and the review services that are running. All I need to do is run a whole bunch more application manifests. The first one is, that's not it. This is the first one. The first one is destination rules. So ISTIO has this concept of subsets. I want to be able to send a subset of traffic to a particular endpoint. And it's an abstraction over various things, mainly done with labels. So if I've got some pods running that have a particular label, I can define that as a subset, which is a potential destination for traffic. So first of all, I have to create the available subsets, which are versions 1, 2, and 3, and they're just picking up based on these labels of what's already there. So my application is still running. It still could potentially be having live traffic, but I can apply this, and I can start shaping the traffic based to the different versions that are there. So let's go and do this. So that just creates some stuff. And then the next thing I'm going to do, it'd be easier if I just have one screen open, wouldn't it? The next thing I'm going to do is deploy an actual virtual service. So the virtual service is based on the service name. So when the product page makes a call to the review service, it doesn't have a long host name, it just says reviews. And so this is where ISTIO hooks in, and it says, when I'm looking for a host called reviews, then it's HTTP, I'm going to route all the traffic to v1. So I could put a lot of complicated logic in here, but to start with, I'm just saying send everyone to v1. So the other two versions of my application are still there, but they're not going to get any traffic now because ISTIO is routing everything to this one. So let's do that, and I'll show you how it works. So that's that, and I can go and look at what that virtual service actually does. And it's going to give me just the output that I've already seen. So I can check that I've got I can check what my runtime rules are. And now when I go back here, hopefully, when I refresh this, I don't see anything other than v1. v1 doesn't have any star ratings. It's just text. So everything's going to v1. So that's the simplest thing I can do. And to get there, obviously, I had to do a whole bunch of stuff. But now I can shape the traffic all throughout my application. And it's exactly the same principle to deal with dozens of different microservices. I have one central place to define all the routing logic, and I apply it with the kube manifest, just like I apply my latest release by doing kubectl apply. So I'll show you a couple more things. I'm already out of time, so I'm going to skip some of these demos. So let me show you some of these other things. So I can do in here. I don't want you there. Have you here. So in this case, I can route based on an HTTP header. So the demo application has a username in this end user header. I can match on that username and send all of that traffic to subset v2. So a particular tester or anyone who I can identify through some sort of HTTP inspection of the traffic, I can route them to a different version. So they're all going to get to version 2. I can do fault injection here based on the same sort of thing. So I've got my rule that says if it's the end user Jason who's a tester, then 100% of those calls are going to have a 1-second delay, so I can see that the application is working correctly if there's a timeout, but it's always going to go to version 2. Everyone else will still go to version 1. So in my live cluster, I've still got all my applications are running, all the users going to the existing version, but the testers can start working out through these other scenarios. I can do fault injection, as well as doing timeouts, I can actually reject all or some percentage of the traffic. So in this case, 50% of the traffic from the service will have a 500 response. It won't even get to the service. ISTIO will just randomly give a 500 response back to these testers so they can check to see that the application handles that correctly. And then I can start doing my actual deployment, my rolling deployment. So there's no matching here in this particular rule. I'm just saying that for the route to reviews, I'm going to send 80% to v1 and 20% to v3. So people will randomly get a distribution there. And when I'm happy with that, then finally I'm going to roll out. I'm going to send everyone to v3. So that's the kind of things you're going to do. The virtual service definition and the routing is actually the thing you care about. So all the stuff in between is just set up that you'll just do once. And this is how you're going to manage your applications going forward. OK, so like I said, I'm running out of time, so I won't do all this demos. So I'm going to go back here. I'm going to try and click this tiny button. There we go. So one thing I haven't got in my presenter's kit is a magnifying glass, but perhaps I should. OK, so very, very quickly, just kind of went through some of that stuff there. This is the traffic management piece. The thing you care about is the virtual service, but be aware there's a whole iceberg worth of stuff underneath there that you need to set up. You need to have a reasonable understanding of that, because this is going to be how your production actually works. The other thing, the other big thing is about security. So I can have my reviews and my product page, I can plain HTTP. There's no security in there at all. But because ISTIO owns both ends, it can apply security for me. So it can generate TLS certificates. It'll have mutual TLS to make sure I can configure it so the reviews component is only accessible by the product page, and there will be certificates to prove that. And it deals with rotating the certs and storing them securely and all that sort of stuff, and even integrates with external authentication providers like Auth0 and Google, I think. So you can actually get the end user's identity and flow that through and route things based on that too. And the last one is about visualization and monitoring what's happening in there. So ISTIO records all the stuff that's happening. It uses Prometheus, it uses Grafana, so there's a whole bunch of pre-written dashboards that you can use. And there are a few other components like Jaeger, so you can do low-level tracing. So you can see the flow of what's happening through your application, and you can drill down and see individual components and see exactly what they're doing. Okay, so let's just do this really, really quickly. So you don't need a service mesh for this stuff. Like for these things, you can do them all yourself. You can plug together open source components, which is mostly what ISTIO is doing. The core work is being done by things that are already out there. Traffic management you can do with DNS if you can do it at a high enough level, and all that stuff about sending different traffic to different versions, you can do that with feature toggles, and you can write code to make that happen. But you're going to be doing that in all your bits where you want these features to happen. Whereas with ISTIO or Service Mesh, you're leveling that up to one place, and you can apply those rules at one single level. So do you need one? Well, there are some obvious points where it would be useful. If you've got services everywhere, like you're already down the road of having lots and lots of small services, and you're losing the ability to keep track of them all, then it's a good fit. If doing a release is really painful because you've got a track record of releases not going very well and people don't trust you, which is not necessarily a coding issue, it could be a process issue, then being able to do these stage rollouts in the real live environment and direct traffic to a small proportion and see what's happening, that's a massive win because you can do that and then you can get confidence built up again and you can go from your one release every 3 months to maybe 2 releases every 3 months. All the code, all the logic that you need for secure communication and reliable communication between components, it's probably already there, but there's a different implementation in every single bit of your application. So if that's going to cause you pain, which it will eventually, you can cut all that stuff out and leave all that to the other layer. And if you're already going down this route, like so we've already got a new application that we're scoping out, we're going to use Docker, we're going to use Kubernetes, you might as well include a service mesh in there because it's not going to add a huge amount to what you're already proposing. So if you've got a pilot that's nice and cleanly defined, adding one bit to it might make sense. But beware of the cost. Now the main thing is it's not really a technology lock-in because there are other alternatives to ISTIO, and they have a fairly common feature set. It's more about architectural lock-in. So if you make this decision, we're going to cut all the communication stuff out of our applications and put it in this central layer. If you then decide you don't want that central layer, you've got to go back to all your applications and put that stuff in again. So just be aware that you're putting a core part of your application somewhere else that you may have to take apart again. This stuff is quite complicated. So the entry barrier is already pretty high because you need to be pretty good with Docker, pretty confident with Kubernetes before you can even start this stuff. And because of that, you're going to get environmental drift where developers are just running Docker containers. Maybe they're doing Docker Compose. Your test environment, I've got Kubernetes for my deployment, but I'm not using ISTIO because it's too much hassle to manage it all. And then in production, I've got Docker, Kubernetes, and ISTIO. They're all different. So you need to be aware of that because that's when problems creep in. And this whole thing is meant to stop that happening. And the last thing, similar to that, it's a distinction between what's running in production and what you care about in your development environment. So actually, it's rather than having a similar set of tools for dev and ops, you're introducing something new which probably only the ops team care about. So devs don't care about that. So they're not talking a common language for what is a core part of the application. And you may see these technologies kind of presented like a timeline. Like you start with Docker, and then you do Swarm, and then you do Kubernetes, and then you do ISTIO. And if you're somewhere on the left, then you're doing it wrong, and it's bad, and you need to get to the far right. Not that far right, obviously. But that's but it's not like that. Like you can be anywhere on this timeline and it's fine. And you can have different projects running on different parts of those timelines, and that's still fine. So it's all picking the right technology for what you want to achieve. Okay, so the demos, only just some of them, but they're all up on GitHub. I did an hour-long version of this session, which you can see a video of there. If you're interested in training videos, then come and see me. I can give you some Pluralsight passes, which is online training. Obviously, come to DockerCon. You'll get a T-shirt like this. It'll say 9 instead of 8, which is just at the end of next month. Sorry I went over. Apologies about that. But I hope that was useful, and I'll be around for a little while if you want to come and chat. Thank you.